Chapter 6 is all about quadrilaterals. And so our lessons will be fairly short. I'll introduce a quadrilateral after today, of course, because today's more of an introductory lesson. But I'll introduce, let's back up. After today, the lessons will be short because I will pretty much introduce a quadrilateral, we'll talk about some properties, and then you'll start doing homework. The difficulty in this chapter lies in the fact that you need to remember all these different properties for all these different quadrilaterals. That's going to cause problems. Similar to the triangle center portion where you had to remember which center was associated with which part of the triangle and all that other fun stuff. The same is true here. You're going to have to remember things like which quadrilaterals have right angles, which quadrilaterals have equal sides, that kind of fun stuff. Okay, but first let's start with a little bit of a review and maybe a clicker that works. It's plugged in over there, right? Okay, so that didn't go so well. Time for new batteries. Hi, welcome to Monday. There we go. Let's review what's polygon. Sarah, what's polygon?
Isn't it like a shape?
Good. It's a good start. I like it. Shape.
Yeah, it has like no curves.
No curves.
Openings or crosses.
No curves. I cut you off at one part. What's the second thing?
Opening, like
It's closed.
Yeah, it's
yeah.
closed.
Okay. And
it doesn't like cross.
right, none of the sides overlap. Close enough. If you look back in your notes early on in the class, we defined polygons. You can refer to that. But these are all polygons. These are not. This one's not closed. This one, the sides cross over. This one has curved side. So remember, circles are not polygons. That's why they don't have circumference. Okay, quick review here. Names of all the polygons. Who thinks they can do all 13? Well, it's not 13. 3 through 12, actually. Okay, go ahead. What's your name?
Triangle. Quadrilateral.
Gesundheit.
Pentagon. Hexagon. Septagon.
Or?
I don't know. Heptagon. Octagon. Nonagon.
Are you asking me or telling me?
Telling you.
Telling me that it's a what?
Nonagon. And then, is that 10?
I don't know. How many was this?
9.
So we went 3, 4, 5, 6, 7, 8, 9. What would be the next logical one after that?
Decagon.
Okay. And then 11?
Isn't it like an
Are you asking me or
octagon?
telling me? You
Telling
said you
you.
knew all of them.
I do.
Okay, so then why do you keep asking me what 11 and 12 are?
Well, I know 12 is a dodecagon. And then, I'm pretty sure 11 is like an onagon or something like that. Or like a, no, undecagon. That's what it is.
Decagon, correct. Let's give it up. Nicely done. She struggled there for a little while figuring out what comes after 9, but once she got through that, got it all taken care of. We're going to focus on quadrilaterals. So, Polygon Sum Theorem. We had already a triangle sum theorem, which said what? Erica, what's a triangle sum theorem? Any exceptions to that rule?
No.
Erica? Okay, correct. So triangles have to always add up to 180. So we would like to figure out a way to come up with a Polygon sum theorem, because we would like to know what's the sum of the angles in a quadrilateral or in a pentagon or an octagon, et cetera, et cetera. So we're going to start with this concept. Triangle. Sum is 180. If I take a quadrilateral and I draw in a segment, I can split any quadrilateral into 2 triangles. What's the sum of all the angles in each individual triangle? And how many triangles? 2. Beautiful. Go to a pentagon. A pentagon can be broken into 3 triangles. Each triangle has a angle sum of 180. There's 3 of them. Gives you a total of
540.
540. You might want to get out your calculators, by the way. You're going to be doing a bunch of work here. Then we go to a hexagon. 1, 2, 3, 4 triangles at 180 each gives you a total of 720. And then I stopped at septagon. 1, 2, 3, 4, 5 times 180.
900.
900. And we can continue with that process. Staying with this idea, would require a bunch of memorization, and I'm not a huge fan of memorization, so we'd like to be able to come up with a general formula to figure out the sum of the angles in any polygon, not just 3, 4, 5, 6, 7. Okay? So, yes, question?
I think I know what it is.
Hold on.
Okay.
So what we want to figure out is how many triangles do we get? Well, this has 3 sides. How many triangles? 1. This has 4 sides. How many triangles?
2.
5 sides. 3. 6 sides. 7 sides. N sides.
And minus 2 sides.
N minus 2. And what's the sum of all the angles in each triangle?
180.
So therefore, the total sum of the angles in any polygon would be
And minus 2 times 180.
N minus 2 times 180. Okay. Where N stands for the number of sides, and S, notice capital S, sum of the angles. S-U-M, not S-O-M-E. Those are homonyms. Come on, you're supposed to know this. You're in school. Homonyms are words that spell differently but sound the same.
No,
Homophones.
Yeah.
It's like spelled the same but sound different.
It's phone means sound.
Yeah, homonym
Yeah,
is
I'm
like
pretty sure
sounds the
it's a
same, spelled the same, but means something different.
I'm
sticking with Carter.
Like wound and wound.
Homogram
Well, that would be
is like spelled the same.
Yeah.
Homophone
Yeah.
sounds the same. Homonym is spelled the
right.
same, and
I'm forgetting all of this. I
Because
don't
name
remember any
name
of
is
it.
like name.
We
and then
did
font
this in
is sound.
6th grade.
I know homo means same. I can tell you that.
That makes perfect sense.
Exactly.
So the answer to my question then is sum and sum, S-U-M and S-O-M-E would be what now?
Homophone is the same sound.
Homophone.
Oh yeah.
See, when I learned this, they never had that word. That's a made-up word.
What?
We never had homophone. I never heard that word before.
Every word's a made-up word.
Well, that's true. Good point.
Ooh. Killer.
That's a valid point. I often thought about teaching my children the wrong words. You know, the right language, just wrong words.
Exactly.
Wait, what?
Just teach them like a banana is a cow. You know, so then they would go to the store
Just
and
mess
ask,
with their lives.
are these cows right? Just little things like that that cause major problems later in life. So if we, hold on, I forget. Let's back up with some terminology. What's a corollary?
I think that's a made up word.
Because as we learned, all words are made up, so yes, you're correct. Very good.
Lines that are together.
I'm sorry?
Lines that are together.
I can't hear you when you got your.
Lines that are together.
No,
Okay.
no, no. Anybody remember the word corollary?
is it in our notes?
I might be.
I don't try to use stems.
A corollary is a theorem that's not important enough to be another theorem. It's like a sub-theorem. Okay, so this is a sub-theorem because this isn't important enough to get its own name. It's a sub-theorem of the Polygon Sum Theorem. And so the measure of one interior angle of a regular polygon. I forgot. Jack, what's a regular polygon?
Equal sides, equal angles.
Beautiful. Equal sides and equal angles. So if n minus 2 times 180 is the sum of all the angles in any polygon, doesn't matter the shape. If it's a regular polygon, then we know that all the angles have to be the same, so I can just divide by n, and that will give you the number of sides. Okay? So for instance, you have an octagon. If I want to know the sum of the angles in an octagon, 8 minus 2 is 6 times 180 is...
Oh.
1,080.
1080, thank you. Now if I want to know the measure of one particular angle, then I can take 1080 and divide by 8 and get... You have calculators sitting in front of you. If you can't do 1080 divided by 8,
125.
135, correct. The important part to remember about this corollary is this little pesky word regular. This does not work unless the polygon is equal angular or regular. Equal angular, all the angles the same. Okay? We good? Make sense? Yeah. Good, let's move on. Find the sum of the interior angles in an octagon. Make sure you read the problem carefully. Did the problem ask you for the sum? Did it ask you for the measure of one angle? What shape is the polygon? How many sides does a nonagon have? Take all that into account before you start solving it. The other thing is to be sure to show work. I don't want answers appearing out of nowhere. Start with a blank formula, plug in what you know, solve for what you don't know. Michael, what do you got?
1260.
Can somebody confirm?
Yes.
Okay, beautiful. Let's talk about how to show work. What formula did you use, Michael?
Polygon Sum Theorem.
Give it to me.
S equals, in parentheses, n minus 2 times 180.
Blank formula. What do you know from the problem? S or N?
N,
N. And what's N?
9.
Plug in what you know. Seven times 180, 1260. Is that what you said?
Yeah.
Yep. Degrees. Easy peasy. Okay. Make sure you show work. I want to see what formula you started with. Question, senor.
Will you take points off if we forget the degree sign?
Probably not. But if I'm in an ornery mood, or if I'm irate, or just crabby, I am going to try to go off caffeine. I'm giving you all advance warning. I'm trying to go off caffeine this week, so things could get a little ugly. Yeah. Well, it's not going to be my problem. It's going to be your problem because I'm going to have my crabby pants on all week. What do you want?
So, and a nonagon, and all 9 angles, it equals 1,260, or all the triangles inside the nonagon equal 1,260?
Yeah.
Okay.
So suppose I had the same problem and I asked you what's the measure of one angle in a nonagon, what would the answer be? Hmm? Oh, I thought you said something. Must have been Wilma. Did you say something?
What?
Huh?
No.
What?
It's 140.
No.
Oh, the wait.
140.
No.
Depends if it's a regular nonagon.
Correct. You can't answer the question. It's got to be regular before you can find the measure of one angle. We don't know how big the angles are. You could have one angle that's 1 degree, and then another angle that's 179. Who knows? It's all over the place. Until you know it's regular or equal angular, you can't answer that question.
Will you ever give us one of those? Just trick us. Just.
My goal is not to trick you. My goal is to make sure you're paying attention. Notice how I didn't answer the question.
I see that.
Uh-huh.
Worked around it.
Yep. Oh, wrong way. What am I doing? I'm going this way. There we go. 1260. Uh-huh. Yeah. Okay. Hey. Find the measure of all 4 angles in the quadrilateral RSTU. Hold on. Before you start work, we did talk about how to name quadrilaterals and polygons, right? Maybe we should review this. If you want to name a quadrilateral or any polygon, but quadrilateral since we're going to be working with them most, you pick any letter and you go in order around the shape. It doesn't matter what shape you go. So there's a lot of different names for this polygon. I could call it RSTU, I could call it UTSR, I could call it STUR. So you could get ruts, stir, utzer, restu. All of those are valid names. What's not a valid name is RTSU. Okay? Good. Finish the problem. Question.
Yeah, does it matter if you go clockwise or counterclockwise?
Does not matter. Make progress?
Yes.
Yeah.
Yeah? Okay, good. Should be ready to go, I think. I'm not 100%. Just start writing, we'll see what happens.
Alright.
There you go. Okay, hold on a second. Where'd that come from?
I didn't show it. Which one's the eraser?
The
Yes.
circle?
Small.
No. Look at him using the technology. Caitlin, what did he just do over there on the left? Not the angle, so Polygon Sum, but yeah, same thing. Probably. I'm just gonna talk about that when he's done.
Yeah.
Get distracted, Carter. Eyes on the prize. That's okay.
Is that right?
I don't know, is it?
I never.
That's what I got from
What's that, guys? It's gotta be right. Alright, tell us what you did. We got the left part, we figure out that you found the triangle, or polygon sum to find the sum of the angles is 360.
Alright, and then, so, you just add up, so that means that the four angles, 11x plus 4, 11x plus 4, 5x, and 5x, that's equal 360 degrees. So that, you just add them together,
Did a little bit of algebra.
yeah,
Okay.
you got x equals 11, so I just plug those into the equations.
Okay. And then you asked the question, is that right? How could we easily check if that's right?
To add if they equal to 360,
Do
I
they?
just got around to it.
125 plus 125 is 250. 55 plus 55 is 110. Is that 360? There you go. We're good to go. Any questions? All right, let's give it up. Nicely done.
It was really fast. I was like, oh my gosh.
So there's the same work he just did. All right, now try this one. You might want to sketch a picture, you don't have to. The reason I threw the word convex in there is because I just wanted to make sure that we didn't have any funky octagons that are collapsed in on itself. It's the standard, plain old, stereotypical octagon. Which has how many sides? 8. Good. might want to start. Polygon Sum Theorem to calculate what? Some of the angles in an octagon. That's the easy part. Then what? Jack?
Do you divide 40? Add up the.
I lost you there. What'd you say?
All this, it says all the sides are congruent except 2 of them.
Sides?
The angle.
Angles. That's
Yeah.
better. Yeah, yeah. We don't know anything about the sides. Okay.
And it says that 2 of the angles, their measurement is 20 more than the others.
Okay, so let's back up to the first sentence. If you got 6 angles that are congruent, what do you want to call those angles?
X.
X sounds good. So if these angles are X, then how big are these angles?
X plus 20.
X plus 20. How many of those do we have?
6. Wait, X minus 20 or X
Well, I don't know.
is plus?
Oh, sorry. I thought plus, I wrote minus. Okay, we got 6 of those. How many of these do we have?
2.
2. And what does that have to equal?
No, well,
1080 triangles, or the polygon sum. Whoop, 10, not 1080. Okay, solve for X, then answer the question. In this particular case, it wants to know find the measure of each angle. So you'll need 2 answers. One for the measurement of X, and then one for the X plus 20. Anybody solve this for X yet? Nicola, what do you got?
130.
X equals
130.
130. So therefore the answer to the question is 130 degrees and 150. Okay. And again, if you want to draw a picture, you can draw a sketch of an octagon and then put the x's in for the angles that you know, and put an x plus 20 for the angles that you don't know, or you can just work it out algebraically. Okay, questions before I erase? We're good? Yeah, Emma. This too?
Yeah.
Because 6 of the angles are just x, and it's an octagon, there's got to be 8 angles. And so the other 2, it says, yeah, the other 2 angles have x plus 20. Okay. Anything else? All right, let's move on. Let's move on. Okay, find x. You'll have to ignore the tick marks. These are obviously not congruent angles. That would be silly. They're congruent angles and one's 120 and one's 130. That's just crazy talk. Trisha, what do you got for an answer?
I got x equals 100.
100. Anybody else? Same answer?
No.
Different answer.
Yeah.
Uh-oh. Yours is way off.
got that.
From 100 or from the right answer? What'd you get, 2?
210.
210.
Yeah.
Yeah, it's an extra 100.
110?
Well, if you add them all together and you
It's
just
110.
subtract.
110.
I got
110, 210, 100, 110, 110, 110, 110, 110. 110 seems to be the consensus. Why 110? Faith, why 110?
Oh, well, I found I used Polygon Sum Theorem to figure out the whole thing, and then
Hold on. What kind of polygon is that? A hexagon, so it has how many sides?
6 sides,
6 sides, and the sum of the angles in a hexagon is
720.
720.
And then I added everything up, including x, and
120 plus 160 plus 130 plus 110 plus x plus 90.
yes.
Mhm.
And then I set it equal to 720, and then I subtracted everything besides x, and I got x equals 110.
Okay. See if I have an answer here. 110. Okay, good. Trish, what'd you do wrong?
I copied it down on there, got 710 minus 160.
Okay, so now we move to the outside of a polygon, and we've talked about what an exterior angle is already. What I forgot. Tyler, what's an exterior angle on a polygon?
It's the angle that the sides inside add up to. Well, not like in a triangle would be the two smaller sides add up to the exterior angle.
You're telling me the exterior angle theorem, but I just want a definition of an exterior angle.
It's an angle on the outside.
Any angle on the outside?
I think so.
Yes? No. Can't be any angle on the outside. What?
It has like an adjacent side.
Yeah, it's gotta be adjacent to an interior angle. So if we draw a picture here, we got whoops. If I extend the sides like this, this would be an exterior angle, this would be an exterior angle because it's adjacent to the interior angle. This would not because that's a vertical line. Okay, so quick refresher on exterior angles. Get rid of that, come back here. What's the sum of the exterior angles of a triangle? So drawing a picture again. If I add that angle plus that angle plus that angle, what do I get? Dee Dee,
You can take a shot in the dark, just 180.
it's not that dark in here.
Ah, lol.
180 degrees.
Not a bad guess. Wrong, but not a bad guess. Alec, 360. Why?
Oh,
Another shot in the dark? Okay, Carter?
draw all of the exterior angles would be supplementary to the interior angles.
I agree.
So if you take exterior angle plus interior angle, you get 180 cents. I don't know. I get it, but I can't explain it.
I understand what you're saying.
1 plus 2 equals $1.80. 3 plus 4 equals $1.80. And 5 plus 6 equals $1.80. That's what you just said, right? So? Let us add, shall we? If I add the left side, I get 1 plus 2 plus 3 plus 4 plus 5 plus 6. And if I add the right side, I get how much? 540. Okay. How's that help us, Carter? You're right there. You're on the cusp, as they say.
Angle 1, 3, and 5 equals 180.
Beautiful. 1, 3, and 5 equal 180. So let's get rid of them.
Subtract 180 from 540. So then 2 plus 4
That's incredible.
Nicely done. That's the easy one. Delete. Quadrilateral. What's the sum? Alec,
Isn't it also 360?
are you asking me or telling me?
It's 360.
He's stating it's 360. Agree or disagree?
Agreed.
Agree? Why? Because he seems like he's really smart?
No, it just makes sense.
Why?
Just makes sense.
It just makes sense. Okay. I'm going to go jump out the window. In my head. I'll be okay.
It makes sense.
Because that makes sense.
Well, no, 'cause you don't have to-
Your logic, my friend, is flawed. What?
Oh, is it? Wait a sec. It wouldn't be. The exterior angles wouldn't be 360.
No reason for violence. So you're saying it's not 360?
No, I think it's. I'm gonna say.
Oh, yeah.
Is this another shot in the dark?
Yeah, 640.
640.
Wait, no, just kidding.
No, no,
Just
no,
kidding.
no, no,
Think of a
no, no,
regular.
no. Grace?
Wouldn't you have to use
It is
Polygon, wouldn't you use the Polygon Sum Theorem and then use the same method that you used for the last one, except like, so like.
Okay, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 would equal 4 times 180 is 720
Yeah, so then,
minus the sum of the angles in a quadrilateral, which is
yeah.
360. So 720 minus 360 is.
Oh my god.
Okay, now this is a high honors class, so I'm going to see if you guys are good with pattern recognition. The exterior angle sum for a triangle was 360. The exterior angle sum for a quadrilateral was 360. What do you think the exterior angle sum would be for a pentagon?
360.
You dogs, you.
780.
Yeah, 1427. Okay, we did all that. There you go. It's always 360. Doesn't matter how big or small, how many sides the polygon has. You add up all the angles on the outside, one per vertex, and you get 360. That never changes.
Well, that's if it's convex.
Yeah, we don't. For the most part, in this chapter, we're going to ignore concave polygons when they cave in on themselves. Yeah, everything goes to heck in a handbasket when it's concave.
Okay.
Why? Okay, it's 360. Just write 360. How long does that take? You writing every word?
Yeah.
Oh, of course. Find the measure of one exterior angle in a regular decagon. There's a couple ways to do this problem. There's an easy way and a not so easy way. Hopefully you're going to use the easy way. In other words, I want to know how big is that angle. Anybody? Ah,
36?
36 is correct. How'd you do that?
Oh,
360 divided by
Oh wow.
you just divide 360 by the number of sides.
Why?
So 360 divided by 10 is 36.
Why? I mean, I know why 360 divided by 10 is 36, but why'd you just divide by 10?
Since and each side shape, exterior angle, all of them add up to 360 since it's a decagon. So it's 10 sides, so you just divide by 10.
Okay. That's the easy way to do it, by the way. If it's a regular decagon, then all the angles are equal. And if all the angles are equal, then all the exterior angles are going to be equal. And so take the sum that you know it has to be and divide by the number of angles. That's the easy way. The hard way would be to solve for this angle first.
And that's what I did.
Uh-huh. And then take the supplement of that angle. You got the same answer, right?
Well, yeah.
Okay. So how did you find the measure of that angle, Faith?
Well, actually, I just did the, what's it called?
I don't know.
The thing where it's like the measure of one interior angle of regular polygon, so n minus 2 times 180 over n. And then,
And when you did that, you got what?
well, I got 1440 divided by 10 is 144. So then the interior angle is 144, and then 144 minus 180 is 36.
Same. They both get you the same answer. Neither one is more correcter than the other. It's just one is a little bit quicker. You could even use this if you wanted to find the interior angle. Suppose I ask you what the interior angle is. You could take 360 divided by 10 is 36, and then take 180 minus 36 to get 144. Okay, but again, only if it's a regular polygon. If there's no regular statement in there, then it doesn't work. And some of you will try that with a non-regular polygon, and you will regret it. Okay, I think, last example. There you go. Find the measure of x and the measure of angle ABC. What kind of polygon is that, by the way? Pentagon. Do we care?
Yeah.
No.
Well, you have to care.
No, you don't.
You don't?
No.
Oh. Okay.
Just had an epiphany.
I would have been doing it the long way.
I was doing it.
Crazy kids. What do you know about the sum of all these angles? It equals 360 because there's one exterior angle from each vertex. So 2x plus 4x plus 3x plus 2x plus 1x equals 360. And therefore x is equal to
30.
30. And therefore how big is angle ABC? It's easy as 1, 2, 3. What? Go. 60. Why?
Because 4 times 30 is 120, and then 180 minus 120 is 60.
Beautiful. We good? Good. Okay, got a little race for you. You ready? Somewhere in your notes, you need a pencil. Put your calculators away. Need a pencil and a small portion in your notes, just somewhere to write numbers down.
How many numbers?
You're just going to do one quick calculation.
Wait.
Okay, I understand. First one done wins.
Is that not?
When you're done, don't shout out the answer, just raise your hand.
What do we win?
Oh, don't worry.
Bragging rights.
Hey.
I think we got time for this.
I don't know if you do. I'm winning this.
Yeah? Got your eyes on the prize.
I do.
Okay. Your ITZ? In the zone?
Yeah.
Oh, you took it back off.
Well, there is no prize yet because there's no.
Ready?
There's no.
Calculators are away, right? Don't use that
Of course, it
calculator.
really won't. Promise.
Break your other wrist.
I'll use this calculator.
I think Nate just wins for them.
Oh, here we go. Do that math problem. Ready? Go.
0.
Oh, you dog.
Oh, I didn't even
You
see
lose.
that.
I didn't even get it. I'm just like, I didn't mean to do that.
What? It's too late. Somebody shout out the answer. There's no self-control.
This is like one of those tests where you put down, okay.
I couldn't see the zero because
Yeah, I
Right.
know. I
Stand up and
couldn't-
stand up and
I
shout out your
read it.
name. Pat your head and rub your belly.
And then do
And then the last one is say do nothing. Just put your
Wait,
name at the
you're
top.
like taking it last minute.
So the new assignment sheets are on Schoology. I will publish the homework in 2 seconds, and then you'll be good to go.
1,
Okay.
2.